Assalamualaikum. Welcome to the channel. Today I am going to show you my complete Tic-Tac-Toe game project built using the 8051 microcontroller. This is a fully functional 3 by 3 Tic-Tac-Toe game that you can play in two modes, player versus player and player versus AI. Everything is controlled by the microcontroller. There are 9 input buttons, 9 output LEDs, mode selection, error indication, win or draw detection, and even a reset button. In this video, I will show you the complete Proteus circuit, explain every hardware part, and then run a full real-time simulation so you can see exactly how the game works. So let's get started. This is the complete schematic you are looking at right now. On the left side, we have the input button matrix. Let me zoom in for you. There are 9 push buttons labeled B1 to B9 arranged in a 3 by 3 grid. These are the buttons you press to place your X or O on the board. Right above the buttons is the right above the input buttons, there are output LED matrix. 9 red LEDs labeled L1 to L9 in the same 3 by 3 grid. These LEDs light up to show the current board state cross or O in each cell. At the top left, we have power selection, a 3 microfarad capacitor and a 10 kilo ohm pull-up resistor R1 for proper reset and power stability of that microcontroller, which is connected to the reset pin of the microcontroller. Here we can see at pin 9. In the center, there is the heart of the project, the 8051 microcontroller, or you can also use AT89C51 microcontroller. It has 12 megahertz crystal connected to the pin 18 and 19 for the clock pulse. On the right side, you can see the indicator LEDs. This LED shows whether we are in player versus player mode or in player versus AI mode. This LED indicates if you try to play in already occupied cell, this will lit up and show you a error message. P1 lights up when player 1 wins, P2 lights up when player 2 or AI wins. Draw LED lights up when the game ends in a draw. Below the indicator LEDs, there are mode selector switch. You can choose between player versus AI or player versus player mode. There is also a start button at the bottom right, and the main reset is handled by the external interrupt button connected to the microcontroller. All connections between the buttons, LEDs, and the microcontroller are made with green wires. You can see the port pins clearly labeled on the microcontroller. P0, P1, P3, all are used. Let me quick summarize the major component. One microcontroller, 9 push buttons, 9 output LEDs, one crystal, one mode selector SPDT switch, 5 status LEDs, and 10 microfarad capacitor, and multiple 10K resistors for each of the LEDs. Everything is powered by a standard 5-volt supply. You can see the 5-volt supply and ground rail at the bottom and the top. We are indicating 5 volt supply from this one and this one. Now let's see the project in action. Here you can see the simulation is now running. All LEDs are off, the board is clear, and we are ready to play. By default, the game starts in player versus player mode. Let me first show you the PvP mode. Player 1 will be cross and player 2 will be O. I am pressing button B1 as player 1. You can see LED L1 lights up as cross as it is blinking, so you can identify it as cross. Now player 2 presses B5, which lights up the LED L5 as O. Player 1 presses B9, player 2 presses B3, player 1 again presses B7, player 2 presses B4, player 1 now presses B8, and player 1 gets 3 cross in a horizontal line. You can see here as these threes are blinking up. So look at here, the P1 LED is lighted up and all other indicators are turned off. This indicates that player 1 is the winner and there is no other indication or no other error in this game. The game is completed. I'm pressing the reset button now. The entire board will clear, all status LEDs turn off, and the game is ready for a new round. Now I am flipping the mode selector switch to player versus AI. You can see the player versus AI LED turns on, indicating we are now playing against the computer. I will play as player 1, pressing B1. Cross appears in L1 position. Now watch the AI's turn. After a small delay, the AI automatically places 0 in the center position L5. I press B9. AI immediately locks by placing 0 in L3 position. I press B7. AI places 0 in L4 position. I press B6. Now, if I had continued, AI would have blocked again. But let's play a different game to show draw and error. Let me show you the error function. I press B1 again. Now try to press B1 again. You can see the error LED blinks and nothing appears on the board. Perfect invalid move protection. Now let's play until draw. If I press B2 again, this will conclude the game and there is no specific winner between player or AI. So the draw indicator will turns on and indicates this is a draw game. I again reset the game. Now this time I will let the AI to win this game. You can see I placed cross in L1, L6 and L9 position. So as usually I didn't win, but the AI placed uh, its turn 0 in L3, L5 and L7 diagonal position. So according to the rules, the AI won the game and the player 2 indicator lights up, indicating that the player 2 is the winner. Now, if I try to give any move again, it won't take that move or show it to the output LED matrix. We have to again start the game. Now I am again shifting the mode to player 1 mode. I'm just simply playing the game according to the rule, and you can see the player one indicator is lights up, indicating that the player one is the winner in this round. Everything works smoothly. The buttons responds instantly. LED updates immediately. AI plays intelligently. Win or draw conditions are detected correctly, and error handling is perfect. So this is my complete tic-tac-toe game on 8051 microcontroller. You see the full hardware circuit in Proteus, every component, and real-time simulation of both PvP and player versus AI mode with all features working perfectly. If you want the Proteus file and the .hex file or the complete schematic PDF, just comment below. I will share the download link. Thank you for watching. If you enjoyed the video, please like, share, and subscribe for more microcontroller projects. See you in the next video. Take care.